Now let us continue with our first unit. It is in this video lecture we are mostly going to complete our first unit. In the second part we have discussed about what is VCR system, vapor compression refrigeration system, and its components, how the phase change is taking place from one component to the other, and we have TS graph entropy for a refrigerant, and we will continue. I've seen the processes. Now we will see pH chart. pH, pressure, enthalpy, and these curves are, the peak point is the critical point, liquid curve, right side it is saturation curve, and we compare the processes 1 to 2. 1 to 2 is an isentropic compression of a saturated wave. The isentropics are inclined lines, just like so. It is not ever as that in the case of TS. Here it is an inclined line 1 to 2. 2 to 3 is a isobaric heat rejection. The whatever the heat absorbed or heat gained due to in two heats during the here in 2 is state superheated state, 2 dry state, intermediate state is shown, and 3 is saturated liquid state. As a whole, the 2 to 3 is an isobaric, a horizontal line where the heat is the atmosphere. As the process is isenthalpic process 3 to 4. H3 is equals to at the point 3 and at the point 4, the enthalpies are isenthalpic expansion actually. So expansion is taking place and the pressure drop takes place from 3 to 4. Next, and isobaric addition. So from 1 it is a dashed line as shown like that. Temperature and T C is temperature, and pressures are TC PE, evaporator pressure. So pH graphs are, draw them. Now Coming to analysis of standard vapor refrigeration VCR system. Evaporator, the function is to absorb the heat from the food item, refrigerated or evaporated space. The refrigerant which after absorbing heat, the will get converted vapor at the end of evaporator. Evaporator is an evaporator. Name itself says that liquid, and at the end we get a vapor form. So in evaporator, heat transfer rate at of refrigeration evaporator is mass flow rate of the refrigerant into H2 H1 minus H formula from energy equation. Study energy equation. We know that in the terms according to now it is second. So it says that Q minus W is equals to H2 minus H1 plus change in potential energy. So in that Q minus W, because the terms W work done is 0, because in an evaporator which is functioning as a heat exchanger, we need not supply any work, or it will not do any work for us, only weakness and work. There is no there won't be any kinetic energy change, much change, or because almost they keep him that height level. So the potential energies and kinetic energies of the liquid refrigerant is to be 0. Only the change in enthalpy is, and that is equated to minus W m dot H1. Here it is to the system, heat given to the system, so H1 minus H4, it should be a positive as per the form. M R E is per second. H1 and H4 are the specific kilojoule per kg respectively. Refrigeration effect, simply refrigeration, which is equal to of refrigerant. Pressure PE is the saturation pressure corresponding to and the analysis is made for a compressor and condenser. Now, when compressor uh, we need a compressor with the help of some compress fluid whatever is entering into it. So work is supplied to the compressor. Here its function is to increase with the help of some work to the compressor is given by H2 minus H1. MO H2 minus H1 is from steady flow each. So the terms like is zero and same kinetic and potential energies zero and will be compressor work out mass flow heat enthalpies to the compressor. H1 minus H2 is known as specification or simply work of compression. Work input to the compressor per gram of refrigerant per kilogram of runtime. It will become m dot H2. We have condenser, an expression for condenser 2. Analysis of a standard. Same. Just like evaporator, we have the condenser. All transfer rate at condenser is given by QC is equals to MR. In all the cases, mass flow rate of into H2 minus greater than the enthalpy of condenser. H3 is the enthalpy of the outlet of the condenser, and they are specific kilojoules per kg. Will this much amount must be lost by condensing medium lost and it will be liquid and outlet is given to the vapor compression system for expansion device. because the expansion device could be considerable. However, if we take control volume well downstream device, then the kind is saying that due to viscous effect, the kinetic energy get dissipated. So that's why equation will be here W is 0, kinetic and potential are 0, so is equal to 4. And while solving the problems, we can use these expressions also. That's it. Thank you. Now we have completed our first unit. Then in the coming video we will see that VAR system, vapor absorption and air refrigeration system.